My dog is sleeping and trying to decide if I should move him. He's snoring. Okay, so let's go ahead and talk about the object-oriented implementation of this SearchStreamGang implementation strategy. And this is intended to provide you with a basis for the other things we're going to talk about. So I'm assuming everybody here knows what object-oriented programming is. If you made it this far and don't know what object-oriented programming is, we have a lot of issues to deal with. So we're going to talk about the use of object-oriented programming here. And you can also see, if you look at the performance of this version, it's a little bit better than the sequential stream version, but it pales in comparison to the other implementations we're going to talk about later. Another key point of talking about the object-oriented version is to illustrate very deliberately and very tangibly the limitations with object-oriented approaches, which is not to say I don't love object-oriented programming, because I do, but as with everything, you have to understand the pros and cons to see where the world is actually going. So the particular code we're going to start with is the code in the so-called ProcessStreamHook method. And ironically, this code for the object-oriented version is actually not implemented by a stream. It's implemented by object-oriented programming. And I actually added this later just to showcase the differences between object-oriented and functional streams programming. So I just kept the hook method called ProcessStream, but it's actually not a stream. But don't think too hard about that. It's not a big deal. We're going to define ourselves a local variable called list of results. And list of results is going to essentially store the search results that we come up with as the result of doing the code we're about to walk through. This is implemented with an array list, and it's going to basically keep track of all the search result objects where matches were either found or not. We've talked about search results briefly in the past. Search results, in this case, is used as an object that keeps track of the things like the title of the work, like Hamlet or Macbeth. It also keeps track of a particular word that we're searching for in the input, like, or a phrase that we're looking for in the input, like, to thine own self be true, or my kingdom for a horse, or whatnot. And most importantly, it keeps track of the list of result objects where matches occurred. Could be an empty list when all is said and done, but if there are matches, it'll occur in this list of result objects. So that's what we're going to use to kind of keep track of these matches. And you can look at the code here. Remember that this code is also the code that uses the collector of method we talked about when making custom collectors. Now, one of the things you have to remember when you use object-oriented programming is you have to make sure that you're very careful and you initialize your fields or your variables. In this case, we have to make sure we say new array list. If we forget to do this, then chaos and insanity will result because we'll be trying to add something to a null reference. The main part of this method is just a good old for each loop. It's going to explicitly iterate or loop through all the works of Shakespeare. So the GetInput method returns a list of the works of Shakespeare as things called character sequences. So for each character sequence, think of a character sequence as just a lightweight string. For each lightweight string, which corresponds to a work of Shakespeare, we're going to go ahead and do something with it. The GetInput method is something that comes to us from the StreamGang framework. It's an abstract method. That's the base part of the abstract class, StreamGang, and that gets filled in by the SearchStreamGang subclass to do whatever's needed to get the input. And there's various ways to get the input. In this case, it basically reads it from a file. We use a char sequence here as opposed to a string to avoid the overhead of doing string copies. It turns out that in modern Java, they made string copies or substrings copy a lot of memory, perhaps unnecessarily. If you want to learn more about it, go take a look at the link at the bottom of the page when that change was made. So as a consequence, it's better for our purposes to use a char sequence because the subsequence method on char sequence can be optimized to avoid doing memory copies when we don't need to. So that's a help for this kind of a program. What we then do is we go ahead and call the ProcessInput Helper method. It's kind of the subroutine, if you will, that's called by ProcessStream, and it's called in a loop. So for each of the inputs that we have, each work of Shakespeare, we're going to call ProcessInput passing in the work of Shakespeare. And what'll come out of that, of course, is going to be a list of search results. We'll see that in a second. And then we add that to the list of search results that we're going to be accumulating here using the accumulator anti-pattern. And what we do then when we're all done with getting the next list of search results, we add it to the list of search results. And remember, if you don't properly initialize that with new array list a couple inches above, all heck will break out and chaos and insanity will ensue. And when we're all done, we'll go ahead and return the search result. Notice also, I should mention here, this has got the dreaded accumulator anti-pattern. It's sequential. It's inherently sequential. We are stuck with sequentiality here unless we do a lot of surgery to the code. So what we get back will be a list of search results that indicate how many times each search phrase appeared in each of the input strings. Let's go ahead and take a look at the object-oriented implementation of ProcessInput. So this takes a character sequence, which is a work of Shakespeare, which is what's passed to it from the driver program. And then the first thing it does is it goes ahead and takes that work of Shakespeare and splits it up into two parts. First, the title, like Hamlet, and then the rest of the text. And so that's why we use the subsequence call, because it does it in a very clever way that doesn't copy data unnecessarily, which is good. Once again, we create ourselves a new array list, which will be the list of results, because this is the subroutine. And make sure you initialize that, otherwise chaos and insanity will result. And then we go ahead and use a for each loop to explicitly iterate or loop through all the phrases we're trying to look up. These are all the famous cliches that Shakespeare said throughout his career. Shakespeare wrote a lot of cliches. It's kind of a joke. And so for each phrase we're trying to find, we use the search for phrase method to go ahead and look up that phrase in the input. And we'll talk about search for phrase later. If we get back something that had any results in it, in other words, if we got a match, we'll go ahead and add that to our list of results. Once again, chaos and insanity will result if list of results is not initialized properly a couple inches above. One of the things that makes this code complicated is it has control constructs. So you have to kind of play runtime system to figure out the flow, and that can be a little bit daunting. This is pretty easy code, but as we would see in more complicated code, you'd have to keep track of loops and nested if-else statements and so on. So that's one of the problems. And then, of course, the other problem here is it implements that accumulator anti-pattern I talked about before. So it's inherently sequential without a lot of extra surgery. It returns a list of search results back to the caller, which, as we saw, was the ProcessStream method. Very quickly, let's take a look at the search for phrase method. This is used to find phrases in an input string. Once again, we have to go ahead and explicitly create a local variable, which will keep track of the array of search results, result objects. We then go ahead and make a regular expression, which is going to take the phrase that we give it and get rid of all extraneous white space and quote any and all question marks, because they're treated specially by the regular expression processing in Java. And then we compile that regular expression in a way that will be case insensitive and will work across lines. We then associate the regular expression pattern that we just compiled with the input string, which is the work of Shakespeare. And then we go into an explicit loop. Once again, we're looping, we're explicitly iterating, and we're looking essentially for all the places where that phrase occurs in that input string by using the find method on the matcher. And anytime we get a find, anytime find matches, it'll return true. And in that case, we make a new result object giving the index where the match began and storing that into the result object. Once again, if you don't initialize results, chaos and insanity results. And when we're all done, we make ourselves a new search results object that contains that list of results, if any, if there's anything there at all. So that's basically how search for phrase works. So this is just a quick walkthrough of the object-oriented implementation. For those of you who've predominantly done object-oriented programming, you're probably thinking, well, that's pretty obvious. That's the way I would have done it. And you're absolutely right. That is the classic object-oriented way of doing things. What I want to show you next, when we come back together again in next class, is how to do this with functional programming and Java streams. which will turn out to eliminate all these weird problems with object-oriented coding where you've got explicit looping and explicit branching, and we've got the accumulator anti-pattern. All those things will just magically disappear, and we don't have to worry about allocating memory. We don't have to worry about control constructs, and we can optimize the heck out of it with minuscule effort on our part.